Welcome to Phase 1, Lesson 3. Volumes, Making Data Survive. Remember the mental model. A container is a process with its own view of the world. Its writable layer is temporary. Stop the container, changes vanish. Delete the container, everything it ever wrote is gone. That is perfect for stateless apps. A web server has no precious data. But what about a database? The whole point of a database is that the data outlives the process. If your database container dies and takes its data with it, you have just lost your production database. The container insight and its flip side. Containers are reproducible. You can always build a new one from the image. But the data is the only part you cannot rebuild. So we eject the data out of the container's ephemeral layer into a volume. A storage box that lives on your host machine outlives any container and can be shared. Here's the picture. On the left, the container, ephemeral. App code, layers, the writable layer. It dies with the container. On the right, the volume, persistent. The data lives here, on your host machine, and survives everything. This is also your first taste of a theme you will meet constantly. The stateless, stateful split. Stateless means you can rebuild anytime. Web servers, APIs. Stateful means you must not lose data. Databases, message queues. Kubernetes draws the exact same line. Stateless sets for the former, stateful sets for the latter. And you will already understand why when you get there. Prove it to yourself with the ephemerality demo. Run a container and write a file into it. First, docker run, -d, --name, temp-box, --rm, jinx. The --rm flag means the container will automatically delete itself when it stops. Now create a file inside the container. Docker exec, temp-box, touch, /i-was-created.txt. Then list the root directory to see it. The file exists inside the box. Now stop the container. Docker stop, temp-box. Because of the --rm flag, the container automatically deletes itself. The file, the container, everything is gone. Now try to access the container again. Docker exec, temp-box, ls/. You get an error. No such container. It is gone. If that was your database's data directory, that was your data. Now with a volume. Docker run, -d, -name, data-box, -v, my-data:/data, jinx. The -v flag attaches a volume named my-data at the path/data inside the container. Now write an important file into the volume. Docker exec, data-box, touch, /data/important.txt. The file lives inside the volume, not in the container's writable layer. Now destroy the container entirely. Docker stop, data-box. Then docker rm, data-box. The container is dead, deleted, but the volume is a separate storage box, so the data survived. Now check the volume. Run a brand new temporary container, attach the same volume, and list the data directory. Important.txt is still there. The container died, the data survived. That is the entire point of volumes. Docker-v, my-data:/data. It means, attach a volume named my-data at the path/data inside the container. Docker stores the volume on your machine. You can see it with docker volume ls, or docker volume inspect my-data to find exactly where the data lives. Any container you attach it to sees the same data. The second type of storage is the bind mount. A named volume is Docker managed storage. A bind mount points a container path directly at a folder on your machine. For example, docker run, -d, -p, 8000:8000, -v, ~web-app:/app, my-web-app:\v1. Now the container sees your live files. Edit index.html on your laptop, refresh the browser, the change is instant. No rebuild, no redeploy. This is how professional developers do local development. Run the container, bind mount their working directory, edit freely, and let the app auto-reload. 3 things to remember. First, containers are ephemeral by design. Treat anything inside a container as disposable. Second, anything that must survive goes into a volume. Databases, logs you care about, config. Third, bind mounts are for development, live code. Named volumes are for production, data. Real production databases use volumes or cloud storage, never the container's writable layer. Your exercise. First, run the ephemerality demo. Actually feel the file die with the container. Second, run the volume demo. Create important.txt, delete the container, resurrect the data in a new one. Third, bind mount your web-app folder into your version 2 web server container, edit index.html, and watch the browser change with no rebuild. Prove it. Question 1. A colleague says, "Do not worry. Our database container has the data inside it." Why is this terrifying? In 2 sentences. Because the container is ephemeral by design. If the container dies or is deleted, the data dies with it, and you have just lost your production database. Question 2. What is the difference between a named volume and a bind mount, and when would you use each? A named volume is Docker-managed storage, great for production data. A bind mount points directly at a folder on your machine, perfect for development, so you can edit live code. Use bind mounts for dev, named volumes for production. Question 3. Your container writes a log file you need for debugging. Where should that file live so it survives the container? It should live in a volume or bind mount, mounted at the path where the app writes the log. Then even when the container is deleted, the log file is safe on your host. Next up, Lesson 4, Docker Compose. That's when your containers start talking to each other as an application, and the whole thing becomes recognizable as real software. See you there. Quick recap. Containers are ephemeral. Their writable layer is temporary. Volumes eject the data out of that ephemeral layer into persistent storage on your host. Named volumes for production data, bind mounts for development. The stateless, stateful split is the same line Kubernetes draws with stateless sets and stateful sets. You now understand why data must survive. Lesson complete.